Hello everyone, and welcome back to my channel. This is Vishnu Manjipudi, and I'm glad that you're here. Today, we will be beginning our Introduction to Chemistry series with an overview of the topic of chemistry. So first of all, what is chemistry? Many of you may envision chemistry as reactions, bubbling and boiling in flasks. Some other of you might associate it with mad scientists. And maybe you might think of molecules, like water. Well, chemistry has all of those things, but it's so much more. Chemistry is quite literally the study of everything in the universe. It studies the atomic level and chemical reactions that make every process occur. So, for example, what about a person? How do they stay alive? Well, you might describe it with biology, but biology is based upon chemistry. Likewise, chemistry is based upon physics, which is based upon math. So, if you think about homeostasis, like the process that an human or an organism stays alive, there are countless chemical reactions going on. For example, cellular respiration, which is C6H12O6 plus 6O2 equals 6CO2 plus 6H2O. The very way that you get energy from substances can be described by a chemical equation right here. So, chemistry is based upon what's known as the atom. This is a simple diagram of an atom. So, you can see here, an atom has three major parts. It has protons, neutrons, and electrons. These three subatomic particles compose most of the matter in the universe. From everything from your table to the window to the car that you may drive in to the computer that you're watching this on right now, everything is mostly made of atoms. There's different kinds of atoms. For example, there's something called the periodic table of elements, which looks roughly like this. So this is the periodic table of elements. It catalogs every single element known to mankind in the universe. And not only that, but it keeps on growing every single day as humans create more and more elements. So let's talk about the basics of the periodic table. So the first element is hydrogen. Hydrogen is one of the simplest atoms, and we'll be coming back to it many times. So a typical hydrogen atom has one proton and one electron. Okay, so let's first define a quantity called the atomic mass. The atomic mass of a single atom is equal to the sum of the masses of all nucleons. So, what is a nucleon? A nucleon is either a proton or a neutron. So, for example, in this atom, there's one proton and 0 neutrons. So, it would have an atomic mass of 1 AMU. An AMU is an atomic mass. In reality, a proton actually has slightly more than one atomic mass unit, and a neutron has a bit more than a proton, but both of them are so close to one that it's virtually insignificant. Additionally, you might say that electrons have mass, but they're only 1,836th of the mass of a proton. So they're generally ignored as well. So now let's try another example. Here we have another isotope of hydrogen. So an isotope, that term that I just used, is a form of an element with a different atomic mass than another one. For example, this is the standard form of hydrogen. It's also called protium. This is a hydrogen atom, but with one proton and one neutron. And this is called deuterium. And now, so to find the atomic mass of this, you would have one neutron plus one proton equals 2. And then there's a third isotope called tritium, which has one proton and two neutrons, like this, along with that one electron. And tritium has an atomic mass of 1 plus 1 proton plus 2 neutrons equals 3. So, however, on the periodic table, you don't see any of these numbers. You get a number for hydrogen that says 1.008. So, why is it 1.008 and not 1, 2, or 3? Well, the periodic table actually describes the atomic weight. The atomic weight here is the average of all masses. It's the weighted average, not just the average, of all atomic masses of isotopes of an element. So, to make things clear, let's do the example of chlorine. So, chlorine has two atoms, chlorine 35 and chlorine 37. So, these two dash numbers here represent the total number of nucleons in an atom, protons plus neutrons. So, first, the problem we're going to solve is how many neutrons are in each of these isotopes. So first, consulting the periodic table, we know that chlorine has 17 protons. So to find the number of neutrons, you just subtract. So for the first isotope, we get 35 minus 17 equals 18 neutrons. And the second one, we get 37 minus 17, which is equal to 20 neutrons. And finally, we can calculate the charge and the number of electrons, assuming that there's a neutral charge, the number of electrons should be the same as the number of protons in an atom with neutral charge, so there would be 17 electrons in both. So another way of writing it, the more formal way than just chlorine-35, chlorine-37, would be Cl3517. Okay? So the Cl is the atomic symbol of chlorine. 35 is the atomic mass. And 17 is the number of protons. So Likewise, the bottom one would be Cl1737. So now, let us calculate the atomic weight of chlorine. So, we know that chlorine 35 appears in a roughly 78% in nature, and chlorine 37 occurs roughly 22%. Okay? So now we have to calculate the ratio. Oh, okay. So we have that chlorine 35 has an isotope abundance of approximately 76%. So we can calculate the weighted average by multiplying the percent and the mass and summing all of them together. So in this example, it would be 35 times 76% plus 37 times 24%. And this is equal to, if you put it in the calculator, you get approximately 35.48, which is very close to the actual value of 35.45. Thus, we can see that this weighted average is pretty accurate. Of course, we didn't include some other isotopes or more decimal places, but this is very good for our standards. So, now that we understand atomic mass, atomic weight, atomic notation, isotopes, and the structure of an atom, we are now ready to venture into the next avenue of chemistry, the atom. See you next time. Thank you so much for watching this video. It really means a lot. Please don't forget to like, share, and subscribe, as well as click the bell icon. As always, if you have any questions, comments, concerns, or recommendations for the next video I should do, please comment down below. As always, thank you so much for watching this video, and this is Vishnu Manjipudi signing off.